All right, so 2.4, complex numbers. So you've probably seen complex or these issues where you have a square root with a negative inside, right? Like, let's say we have square root of -1. And you're like, oh no, I can't find the square root of a -1, it doesn't exist. That's where complex numbers come into play. Square root of -1 is equal to I. So anytime we're simplifying these, we can write them as, let's say if we have 5 plus square root of -5, we can write this as 5 plus square root of 5 times square root of -1. Square root of -1 is, in fact, I. We always write our complex numbers in this form, right? There's going to be a real coefficient in front of I. If it's just I by itself, or like a 5i or 10i by itself with no number added, it's still considered a complex number, but we can also refer to it as a pure imaginary, just simply imaginary number. Let's say we do some adding and subtracting with this. So if we have, for sums, let's just give you a formula here. We have A plus BI plus C plus DI. We add the i's together and the non-i's together. So it'd be A plus C plus B plus DI. Okay? And if we're subtracting, this was minus instead. Subtracting will be A minus C plus B minus DI. Alright, so we got first example here, so I'm going to take 5 minus a -3 minus 2 for my reals, and then there's no I with the 5 in front, so it's just going to be 2 minus 1I. Subtract it, you'll get 6 here, and then 2 minus 1 is 1, so it'll be 6 plus I. All right, we have 3 different multiplication problems, so let's get started. Let's do the one on the left, in black. So we FOIL just like we would. 3 times 2 is 6. Outers first. 2 times -I is -2I. Inners will be 15I. And then 5i times -I is -5i squared. Now when we simplify, the inners are going to go to plus 15i, because -2 plus 15 is 13. And then I squared, just a little recap here, square root of -1 times square root of -1, anytime we're multiplying 2 square roots like that, it's just what's the inside, right? So just -1. So in this case, it's the same thing. So it'll be -5 times -1, which is 5. And 5 plus 6 is 11. Time for the red problem. So for this, we'll get 4 plus 6i minus 6i minus 9i squared. And 6i minus 6i is 0, and then I squared is equal to -1. -1 times -9 is 9, so 4 plus 9 is 13. And the last one, do not distribute a square. Whatever you do, please don't do that. So 5 plus 3i times 5 plus 3i. Okay, do not distribute a squared. It's whatever the expression times itself. Then FOIL, 25 plus 15i plus 15i plus 9i squared. 15 plus 15 is 30. And then I squared is -1, so plus 9 times -1. And that's going to get us -9. -9 plus 25 is 16. 16 plus 30i. There we go. So complex conjugates are important. On the last page here, you actually multiply by 2 complex conjugates. It's whenever we have a real number plus imaginary number, and then the imaginary is opposite. a minus bi. So these two are complex conjugates of each other. See how we have flipped the middle sign, and this real number is the same. That's what makes it a complex conjugate. So if I ask you to write this in standard form, and this being 3 minus I over 2 plus 4i, what you're going to do is multiply the top and bottom by the denominator's complex conjugate. So that's going to be 2 minus 4i. Then we FOIL. Numerator is going to be 8 minus 12i minus 2i plus 4i squared. Denominator, what's nice about the complex conjugate is it gets rid of the i's in the denominator. So it would be 4 minus I plus 8i minus 16i squared. Negative 8i plus 8i is 0. Negative 16i squared is 16, so we're going to get 20 on the bottom. And then for the numerator, 4i squared is going to be negative 4, so negative 4 plus 8 is 4, minus 14i. We can simplify this. We can factor out a 2 everywhere, so it would be 2 minus 7i over 10. You might also write this as 1 over 5 minus 7 over 10i, if you are separating them. All right, we have a quadratic equation we need to solve using quadratic formula. So we need to go negative 16 plus or minus the square root of 16 squared minus 4 times 4 times 17 over 4 times 2. Negative, or excuse me, 16 squared is 256. And 4 times 4 times 17 is 272 over 8. It's going to be negative 16 plus or minus. Ooh, it's going to be the square root of negative 16 over 8. And we all know that square root of negative 16, we can take out an I. And also square root of 16 is 4. So it's negative 16 plus or minus 4i over 8. There's a factor of 4 out of all of them, so we can simplify even more and get negative 4 plus or minus I over 2. And those are your two solutions. I appreciate you watching, and we'll see you later.